This will be hopefully a very short video walking through two calculator skills associated with section 10.1. We're going to focus on two commands available to us from the test menu on our calculator, the two proportion z interval and the two proportion z test commands. We'll use example 1 from our 10.1 notes where we did a confidence interval. We'll use example 3 where we did a hypothesis test, again from our 10.1 examples. So let's go ahead and get ourselves started. You might recall, just from the notes we worked through the other day, example 1, we were comparing teen and adult social media use, and we were trying to develop a 95% confidence level, as memory serves me. That's how the context of the problem is. How do we do this within the context of the calculator? We're going to use a series of the parameters right up here to get ourselves going. So, bringing my calculator back on. Have some stuff already hanging out there. Let's make sure I turn so you'll be able to see. I'm going to run stat, move over to test, and I'm going to scroll down until I see the two proportion z interval. In my calculator, that shows us menu option B. So I'll choose it. And now I've already pre-filled the parameters, but take a look at what they're asking for. They're asking us for the x1 and n1. Well, my n1 was 799, and 80% of that, well, 80% of 799 is a little bit less than 640. And so just for rounding purposes, I said, hey, I'll go with an integer, 639. That's a pretty close approximation, 80% of 799. Would have loved for the numbers to be perfect, for this to be 800, and I could have been in 640. Such is life in the big city. We'll just deal with it. And my second parameter, as you can see, well, 69, or the closest representation to 69% of 2,253, turns out to be 1,555. Have four values in there. I'm asked for my confidence level. In this case, it was 95%. I'm happy. I'll go calculate. What's interesting, there's your confidence interval. It's about 7.6% to 14.3%. Slightly off from the numbers that we had, but not by very much. Again, remember, there's more precision in the calculator. We were doing some rounding work. What's interesting is we see the actual values of p hat. Almost 80%, just about 69%, just as we're expecting. And so calculator very quickly can generate that confidence interval for us. So that's the two proportion z interval command on the calculator. All right. Now in example 3, we were running a test to see, or a hypothesis test to compare the effects of this drug. Did it reduce heart attacks? We found out that it was statistically significant and gave us enough information to reject the null hypothesis that assumed that they were just as effective. The placebo and the drug treatment were essentially the same. We got all our raw numbers this time, so we actually had some real percentages. Again, maybe some rounding errors, fine. But what can we do this go around on our calculator? Well, here we are. Give me a sec. Turn on the light. So test, we are now going to run right off the front menu a two proportion z-test. And look at what's going in here. 56, 2051, 84, 2030. Always remember, last thing is we're just asked, well, what's our hypothesis? Well, our hope is that P1 minus P2 is less than 0. And for that to happen, what do we need? We need our P1 to be what? Less than P2. So that's the size, that's the way in which we want to set up our alternative hypothesis. It's written this way, P1 minus P2 less than 0. On the calculator, you'll have to translate that into one of these two pieces if you're doing a one-sided test. Obviously, if you're doing a two-sided test, it's going to be pretty easy as to what alternative you'll draw. I'll run, take all of my values, I'll be happy with them, hit calculate. And what do I come back with? Well, I come back with a z-score. That's pretty neat. It looks like just like that negative 247 that you see traipsing around right here by my finger. And if you run our p-value, you see it also. 0.0067. Again, because of rounding, we had 0.006. Do you get a p-hat? You get a couple p-hat values, a little bit more precise than the values that I put in, 0.27 and 0.41, but fine, enough to work with, certainly, for sure, as we work through this. And what do we have? We have a probability of 0.006. We said we wanted to work at what? A 99% significant, excuse me, at a 1% significance level. Are we good here with rejecting the null hypothesis? That value, 0.006 for our p-value certainly tells us that we have enough evidence that allows us to reject the null hypothesis. So, very quickly, those are the two key tests, calculator skill-wise, that you can use out of section 10.1.